All right. So here we go. We want the volume of the region enclosed by those two graphs, and we're going to make cross sections which are squares. Okay? So this is the base of the square. So I'm going to try to draw a 3D here. So this is this long. So it's going to look like this. If you think of this going straight up and down, okay, that's a square because it's this length is the same as this length. So this length here is the same as this length here, which is the height of it. Okay. When you get over to here, this height is going to be this, the distance from there to there. They're all squares. So what you're doing is making all kinds of things, and they kind of connect up like this. And it's kind of a square funnelish type thing going this direction. Okay? So, what is the volume of that thing? We want to know the volume of all those squares put together because this is a solid piece of whatever. Okay? What's the volume? Well, to do that, we use subtraction here to find the height of our squares. Okay? So this will be the height of our squares when we subtract. And then how many squares we have depends on this distance. Okay? And so, what we have to do is work with integrals. Okay? So we have to take the top minus the bottom. Okay? And our squares are going to be perpendicular to the x-axis, so like I drew them here. They're going to be this way. Here's a square, here's a square, here's a square, here's a square, 3D wise, and so on. Okay? So these are all squares. So we're going to take and find the distance from here to here. Well, what is the x value of this point right here? The x value of it. This point right here. 0. What's the x value of this point here? P. So we're going to go from 0 to P with ours. So we're going to go from 0 to P. So it's either this one or this one. Okay? And if we find the area of a square, the area of a square is the base times the height. Well, the base and height are both the same things, right? So what's h times h? Which is h squared. So we have to find the distance between these and square it. The distance between them and square it. Okay, so that's what we're doing today, is finding the distance between and squaring it if it's a square. Now, if it was a rectangle, then we'd be doing more of this, okay, where the height, they'll tell us what the height is, so we take the difference of these times the height. But when it's a square, we're looking for the one that's squared, okay, because the base times the height is the same as each other, okay, and we just have to get the horizontal distance of how far that happens from, so those are all the integrals, okay. So for this one, here's what it looks like, and too bad I can't fit all the answers on here, okay. Again, we're going perpendicular to the x-axis, so I'm going to have are we doing squares or right? Oh, here's a rectangle this time. So the rectangle's height will be 4 minus x. So there's a rectangle. There's a rectangle. There's a rectangle. And they'll get smaller again. And so on. Okay? So longer rectangles and smaller rectangles, but they all have the same height. Their height is going to be that. So what we have to do is remember to take the top curve minus the bottom curve. The top curve is our g of x. My bottom curve here in between these 2 points is f of x. So it'll be the integral of g of x, 4 minus x, minus f of x, x minus 2 squared. This is our base times our height, which we're told down below is 4 minus x, because it says whose height is 4 minus x. And then we're going to take that integral from the starting value of x, which is 0, to the ending x value, which is 3. So from 0 to 3. Okay? So from 0 to 3 of these two multiplied. If it was a square, it'd be this one. But since it's a rectangle, it's this one. See the difference? Okay? Okay, let's look at this one. I'll just go like this. All right. So these are squares. Okay? So it's the integral of the top curve, which is this, minus the bottom curve, and we're going to square that. And we're going to go from 0 to 4. Okay? So if we do that, we got to find the right answer. And none of them match mine. Why don't they match mine? And I know it's kind of small. Why don't they match mine? What's different from mine to theirs? What'd they do? What property did they do? The distributive property. Boom, boom, boom. So positive 1/4 x minus 1. So when I was going through these and I was guessing, when I was figuring them out, I got this one wrong because, I just immediately went to the minus sign and said, it's a minus sign from 0 to 4 minus, boom, wrong. And it's like, what? And then I looked and it was like, they distributed. So you got to be careful there. Okay. All right. Last one. Okay. This one. Okay. These are squares again. Squares. Okay. Now, what do we got going on here? Well, we got the integral. What's my top curve? 3. What's my bottom curve? Log base 2 of x. From where to where? Because we're going perpendicular to x-axis, so same thing. So it's 3 to wherever. Ooh. Where is the wherever? Wherever log base 2 of x is equal to 3. How do we do that problem? Do you remember logarithms? This to this power equals this. 2 to the third equals x, right? So what's 2 to the third? 8. Three minus log base 2 of x squared, because it's a square. Okay, so those are the types of problems we'll have before lunch. And then After lunch, we'll deal with semicircles and equilateral triangles, which are a little more difficult than these. Okay, lovely. So let me put that assignment out there. We'll start.